last session, we talked about reinforcement and the schedules of reinforcement. Now we're going to complete the range of possible ways in which the environment can control behavior by looking at what is almost kind of like the flip side of reinforcement, which is punishment, and completed with escape and avoidance. So as you'll see, what we're going to do is really complete a matrix of possible ways in which the environment may either promote behavior or discourage behavior. So let's go. Let's try to put this in context. Recall when we were talking about reinforcement that we were talking about the let's put it here, the presentation of a stimulus, right? We were talking about how a stimulus, a reinforcer that is presented in different arrangements may have different effects in behavior, different ways. When we talked about schedules of reinforcement, we talked about the different ways in which the presentation of a stimulus, the arrangement of that stimulus, may maintain behavior. Alright, so we talked about the presentation of a stimulus. So let's write here what the response causes is a blank of a stimulus and that blank is a presentation of the stimulus. And what does it do to the stimulus, to behavior, to the response that causes that presentation? Well, if we're talking about reinforcement, we're saying that it increases the probability of that response. The contingency, the fact that the stimulus is contingent on the response, produces an increase in the response. Alright? And we refer to this arrangement as positive reinforcement. Okay, but if you think of it logically, there are at least 3 different ways in which responses and stimuli may be related. One is that the response causes a presentation of a stimulus, and as a result, this contingency decreases the likelihood, decreases the rate of the response of the behavior. And this is what we would normally call punishment. Some people may refer to this as positive punishment, just like with reinforcement we're referring to it as positive reinforcement. And what positive means in this case is that a stimulus is being presented. It's not that it's good, it's not that it increases the behavior. In fact, punishment decreases behavior. Is that the response results in a presentation of a stimulus. So oftentimes punishment may be called positive punishment in that sense. And the stimulus would be called a punisher, just like the stimulus that is presented in positive reinforcement is called a reinforcer. Right? Now the response can cause something else other than the presentation of a stimulus. It may cause the removal of a stimulus, right? And that removal may increase or decrease behavior. Let's start with uh, the simplest arrangement, which is that the response causes a removal of a stimulus, and such removal decreases the likelihood of that response. That is what we call oftentimes omission training. And it's also it's sometimes called differential reinforcement of other behavior, also known as DRO. They're all essentially the same. Omission training, differential reinforcement of other behavior. Is the idea that something is that the response causes the removal of something that is present, and because of that removal, reinforcement decreases. This is a uh, this is a technique that is often used when in applied settings, when when we're aiming at decreasing the frequency of a problematic behavior without resorting to punishment, which is the other alternative. Instead of presenting something that is aversive, we remove something that is appetitive, um, that may work as a reinforcer itself. So think, for instance, a typical setup is attention and social praise, which works as a reinforcer. And many kids, many infants, particularly those that have, a kid that has developmental disabilities, and you are training this kid some skills, for instance, and sometimes the training of these skills is disrupted by some problematic behavior, like for instance stereotyped vocalizations. The kid starts repeating a syllable over and over and over and over and over, and it just completely disrupts your training. And so you may want to reduce the the frequency of that behavior. And of course you could do it by punishment, by introducing something that is aversive to the child. Oftentimes that's problematic because that stimulus in itself elicits other behaviors that they themselves may interfere with training. Oftentimes these are emotional responses to an aversive stimulus. But an alternative is to provide a reinforcement of other behavior, of non-stereotype vocalizations, and remove it when the vocalization happens. And this can be attention and social praise. The kid may be receiving on the average, every 30 seconds, every minute, a praise for progressing in a task. But the moment that the vocalization starts, praise and social praise and attention is removed. And that removal of that stimulus may produce a decrease of this vocalization behavior. Right? So here comes now, I'm going to fill up the last cell in this matrix, which is how the removal of a stimulus may increase a behavior. And this is what we refer to as negative reinforcement. And it's really important to distinguish two concepts that are often confused, which are negative reinforcement and punishment. Negative reinforcement and punishment. Um, they're not the same as suggested by the different position in this matrix. Punishment involves the presentation of a stimulus that decreases a behavior. Negative reinforcement involves the removal of a stimulus, typically the removal of an aversive stimulus that results in increase in behavior. And remember, all of these cases are all contingent on the occurrence of a response. So the response removes a stimulus that is aversive, that increases the behavior, then we're talking about negative reinforcement. Reinforcement always refers to an increase in behavior. Um, the positive or negative adjective refers to whether a stimulus is presented. Typically, the appetitive stimulus is presented when, in the case of positive reinforcement, an aversive stimulus is presented in the case of punishment, but an aversive stimulus may be removed in the case of a negative schedule, and then we're talking about negative reinforcement. By the way, oftentimes, as you may guess, people refer to omission training and DRO as negative punishment. That's not very common, but I suppose it's valid given their position in the matrix. In any case, when we're talking about negative reinforcement, we are talking about two. We're interested in two particular forms of negative reinforcement. We're talking about escape and avoidance, which are not the same, but they are very similar and very easy to confuse them. In both cases, we're talking about a behavior canceling an aversive stimulus. And because that behavior cancels an aversive stimulus, it results in an increase in that behavior. Right? The difference between escape and avoidance is when the cancellation of the aversive stimulus happens. So with escape, we're talking about that the cancellation happens during the presentation of the aversive stimulus. And in avoidance, we're talking about the cancellation of the stimulus before the presentation of the stimulus. In escape, we're talking about cancellation of an aversive stimulus during the presentation of the stimulus. In avoidance conditioning, we're talking about the cancellation of the aversive stimulus before the presentation of the aversive stimulus. All right. So, just one example of escape conditioning, escape behavior, is walking out of a bad movie. Right? You walk out of a bad movie and you're canceling an aversive stimulus, the movie, but you do it while the movie is being presented. So you are watching the movie and you don't like it, and what that does, the fact that you can walk away from the movie probably, and that cancels the presentation of the movie to you at least, results in an increase in uh, walking out behavior in the presence of that movie, right? The avoidance counterpart of this example is not going to the movie in the first place if you know, if there's a signal that tells you that the movie is it's going to be bad, it's going to be aversive, right? um, Traffic jams, another aversive stimulus. We may escape from a traffic jam by taking an alternative route when we encounter a traffic jam. That's an example of escape. We're canceling the traffic jam stimulus while it is happening, right? And an example of avoidance, though, is not getting up early, for instance, and leaving early so that you avoid the traffic jam. You don't even encounter it, you cancel it before it even happens. Right? Now, the typical example in the laboratory is what is called shuttle box. It's the example of the shuttle box escape avoidance conditioning. Now, what this is it's a very simple setup. Imagine you're looking at a sort of a chamber from above. You're just looking at it from above, and it typically has some kind of a division, divides the chamber in two, and the chamber, each side of the chamber has different um, you know, visual and olfactory stimuli, so they're easily distinguishable. And the critical thing is that the floor is made up of bars that may be, electrified mildly, and so food shock may serve as an aversive stimulus. And so the way that you can train escape behavior is simply by electrifying one side and not the other, the side in which the animal is present. And so if the animal is here, oh, by the way, this is division, there's a little door here. I failed to mention that. The animal can transverse this chamber, can go from one side to the other through this door. And so this is your animal, seen from above. It's a rat, so it has a tail, right, and whiskers. And so you present foot shock on this side, and what you'll see is that the animal runs to the other side where there is no foot shock. And then once here you present foot shock and the animal moves back. And we'll just demonstrate, escape behavior. Escaping because by moving to the opposite side of the chamber, it is canceling its contact with the foot shock stimulus. Right? Now here's what's particularly interesting. Let's see if I can erase this. Alright. Suppose that now you give some kind of warning. You have a little light here. That's a light. And 5 seconds or 10 seconds before providing foot shock, you turn on the light. So it serves as a warning signal to the animal that foot shock is about to happen. And so now the animal can avoid food shock by moving to the opposite side of the chamber when the light is on. Right? So if you think of it, what that involves is the animal having learned an association between light and food shock. This may sound familiar. This is Pavlovian conditioning. But that association is cancelled by the behavior of the animal. The animal is moving away from the side that it's going to receive food shock, and by doing that, it's canceling the presentation of the US. This is your US. This light is your conditioned stimulus. But notice that the presentation of the US depends on the animal not making a response. If the animal makes the shuttling response, it goes to the opposite side of the chamber, then the US is not presented. This is a particularly interesting learning phenomenon, because as you can imagine, you may have another light on the opposite side that does the same thing, that is, as the other light. That is, that when it's illuminated, it signals that this the right hand side is going to be electrified, and you may see the animal. An animal that has learned to avoid food shock will run to the other side, and you can have the animal run from one side to the other just by turning on the lights. Now this is really interesting, because if this is simply Pavlovian conditioning, recall that Pavlovian conditioning happens because of the association between CS and US. Well, if the animal is avoiding the US, then this is really, in Pavlovian terms, this is extinction. The CS is being presented without the US, yet the behavior of the animal is maintained. In fact, in many experiments it has been shown that you can cancel the US altogether, and a well-trained animal may shuttle from one side to the other just by turning on and off the lights. That is, this shuttling response, this avoidance response, is highly resistant to extinction. Right? And this is an interesting model for a lot of behavior in humans. Think about superstitious behaviors, for instance. How you do some things in a certain way. You carry, people in sports oftentimes carry, when they're performing, they have some amulet or some token of good luck, and they persist using it, even though it may have nothing to do anymore or at all ever with the performance of the athlete. Why does it persist? Well, because it's always being used, and if the athlete is successful, well, why not continue using it? It's always been associated with the avoidance of failure, similar to just walking or shuttling, the shuttling behavior of the rat when the light is turned on, even when there's no food shock, even when there's no need to move to the other side to avoid shock. Alright, this concludes this part. There's a second part, there's a second video in which we'll talk a little bit about how negative reinforcement may actually